Yes, friend. Now I come here just to tell you about Stephen's law. So we are studying here radiation. Actually, this topic relates to the transfer mode of heat, radiation. And I told you every hot body keep on emitting radiation. If body is at 0 Kelvin, then only it stop radiating energy. I told you MSC power of body. So at any temperature, MSC power of body defined as the amount of energy radiated per unit area per unit time. And if I take wavelength y, so per unit wavelength range, which is called spectral radiancy or spectral MSC power. Then how does the MSC power depend on temperature? Stephen law relates the MSC power of body with temperature, or it also relates the amount of heat radiated by a body with temperature. So according to this law, please first understand why we are studying this, what is the purpose of particular topic. And I'm teaching here you the radiation. I told you many things about radiation, Kirchhoff's law, MSC power, and absorptive power, etc. So how does the MSC power depend upon temperature? So actually, this law initially was stated by Stephen for black body. According to this law, the MSC power of a black body, MSC power of black body, that is, I will write here, that is amount of energy radiated per unit area per unit time is proportional to fourth power of its absolute temperature. Black body, I told you, is the body which absorbs all radiation and it emits all those radiation in the range which it has absorbed when it is being cooled. So when we have a hot black body, and we have placed in an environment whether lower or higher, so it keep on emitting energy in the form of radiation. Those radiation may be visible light, maybe infrared radiation. When you heat iron, you might have seen iron being heated in furnace. First that appear red. Before that heating, that we feel hotness from far away, but not visible by eye, or you touch the body and feel body hot. But if you raise temperature further, the body start appearing red and then yellowish, white, and then when at melting point it is exactly it exactly appear white. So black body is not the only thing which absorb radiation, but when a hot body is placed somewhere, it keep on emitting radiation. So that MSC power of black body, that is the amount of energy radiated per area per time, is proportional to fourth power absolute temperature, that is E, proportional to T to the power 4. T is the absolute temperature. E is the, what is E? MC power, that is amount of energy radiated per unit area per unit time. So we write E equal to sigma T to the power 4, where sigma is constant of proportionality, where sigma is constant of proportionality. And is called Stefan constant. Stefan's constant. Do you know what Stefan did other than this? James Watt proposed that heat can push the thing. Using that fact, Stephen was first person who constructed or who discovered heat engine. It is that Stephen. Stephen he now discovered heat engine, and hence Stephen constant. Value of sigma here is equal to 5.67 10 to the power minus 8 watt per meter square per Kelvin 4. Is that clear? Joule per second, na? Energy amount, na? So this is value of this. But now I told you that every body keep on emitting radiation. It will stop radiating energy when at 0 Kelvin. So when we place hot body, black body in an environment, it receives the radiation at same rate. So Boltzmann corrected Stefan law. By saying that when black body is placed in an environment at temperature T0, then it receives radiation या radiant energy which is proportional to fourth power of absolute temperature of environment fourth power. ठीक. So net amount of energy lost or gain. Actually, if temperature environment are higher than black body, so there will be net amount of it received. And if it is at higher temperature environment, then we can write E minus E dash. E is the amount of heat radiated, E dash received. Net loss of sigma T to the power 4 minus T to the power 4. Delta E कह सकते हैं आप. This equation is called Stefan-Boltmann law. This equation is called Stefan-Boltmann law. So this was regarding the black body, and it is the delta E is the amount of energy received per unit area, emitted per unit area per unit time. If black body has area A, then in time T, how much energy will be emitted? Now, if a black body has area capital A, then total amount of energy radiated by black body in time interval, let me write delta T, is given by delta E is equal to, I can write it as delta Q, that is delta E into A into delta T. और ये हमारी डेल्टा ई क्या है? सिग्मा टी पावर 4 माइनस टी की पावर 4 into A delta T. But I told you that every body radiates energy. Then how to determine the heat radiated by any other body which is not a black body? अगर कोई बॉडी ब्लैक बॉडी नहीं है तो उसका हीट एनर्जी एमिशन कहने के मैंने लिख लीजिए बात ये इफ स्मॉल ई बी द एमिसिव पावर ऑफ ए बॉडी with respect to black body, यानी कि amount of energy created by body divided by amount of energy black body. That ratio is E. Then heat radiated by this body क्या होगी भाई डेल्टा Q इक्वल टू सिग्मा इंटू टी टू द पावर 4 माइनस टी टू द पावर 4 इंटू ई ए डेल्टा टी is the time interval. This unit will come out as joule. This will come out as, so this is all about Stefan-Boltmann law. Now, when temperature is much higher than room temperature, the rate of loss of heat will be much faster, because by delta Q जो है proportional to T0 proportional T minus T4 fourth power. By if it is at 100 degree centigrade, environment 10 degree centigrade, तो 100 की power 4 means 10 की power 8. और अगर कहीं temperature of hot body is suppose 20 degree centigrade, so this rate of loss of heat will be very small. So there is one question here. If we take two bottles, one of hot water and other of water at room temperature, and put them in freezer, then which bottle will get freeze first? We have two bottles of water, one at very high temperature, other at very low temperature. So which bottle will get freeze first? This is a question here. At higher temperature, delta Q proportional to T to the power 4. The bottle which is at higher temperature will get freeze first. It is due to Stefan's law, nothing else. ये 1 mark क्वेश्चन आता है ऑब्जेक्टिव टाइप. Now टाइम भी होगा. In next video I will take Newton's law of cooling. Thank you.